believe recording in progress is a good start of our meeting, and really glad to see even more and more new people on our R&D talk. There is an online meetup where R&D experts and special guests are sharing the insights from newest technologies, industry trends, as well as how it can benefit the industry and humanity overall. Our today's speaker will be Daria Hemmerling, who is leading a team at SoftServe, R&D team, and she's specializing in AI-driven signal processing, especially voice processing, but including audio gen AI, and with a focus in a healthcare and education domain. She had an expertise managing EU grant called Touchless that also will be mentioned a lot today. She holds a professor title with a scholarship, but that's not only one of her achievements. But the one that I want to highlight is that she is recognized as a top scientist in Poland for just like probably, yeah, last year. And she's known as the person who integrates advanced AI research with a practical implementation. And today, the topic will be pretty amazing. It'll be around one of the, I would say, possible use case for new technology as Gen AI for creating comprehensive storytelling that includes different modalities, from generating the haptic patterns with haptic devices alongside with audio-visual generation by latent stable diffusion models. I believe it spot some of recent advances of Daria's team on how this combination can help to create immersive narrations and indeed help to engage the audience in a completely new way. So I encourage you to ask questions. They will be neither answered during the session if they're relevant to what the speaker presents, or in the end on the Q&A part. And Daria, the stage is yours.
Hi, let me share the screen first. I just need a confirmation that we can see the first slide.
Yes, we do.
Yes. Okay. So welcome everyone in the afternoon and in the morning today. And I have this huge privilege to lead today the presentation about the Gen AI for storytelling. As Bogdan mentioned, I'm Daria Hemmerling, and I've been the SoftServe R&D lead. For the last 3 years, I'm leading the Touchless project, which we make together with the consortium in European Union, which I'm going to tell you a little bit later. But the all work would not happen without my gorgeous team that is mentioned here. It is Maciej Stroiński and Mateusz Kowalewski and Kamil Kwarciak who had the major contribution to the final solution that I will talk today. And now now it works with the mouse. So today I will talk about 4 major threads. The first one in general, the theory behind multimodal Gen AI. And then I will smoothly go to the goals and motivation behind why we created such a project and the demo. And then we will dig into more technical details, the process, how we created it, since it consists of different, pretty difficult already algorithms. And then we will talk about the case study that we have performed to see if we have any contribution, if we can make even people happy or more engaged into the immersive world. So firstly, let's dig into the multimodal Gen AI. So the first question is about what is the multimodal? And the multimodal is the approach that contributes to different modalities. It means that different sensations like the visuals, the touch, the sound, the general experience that we can face. We are missing here only the smell, but this is something that future might bring. And we combine all of the technologies that enables us to visualize, to create the auditory experience, to create the touch experience as well, to hear also the speech as the narrative of the talk, into one immersive storytelling that that we enable the user to create his own story, visualize the imagination here. And then another question is about the Gen AI. What is it? I think most of you already know that it's the part of the artificial intelligence, a little bit different in scope of the goal in comparison to traditional AI, because here we generate the content that never existed before, based on the huge, vast amount of data. And let me go next. So here we talked about the visualize, about the audio, and the audio is expanded also to the touch sensations creation. And here we contribute in the project with the Ultra Haptics company, who serve us with a gorgeous equipment to create the touch feeling in the air. There are the box that creates the touch sensations is that consists of the many different speakers, which are based on the transducers that create the ultrasound waves. Then we develop it in this way to create the touch sensation somewhere in the air. We define the length from the distance from the haptics box, and the old technology is named meter haptics because the touch sensations happens in the air. And here on the right image, you can see the ball that is visualized. It is not really seen on the normal like in the normal real life scenario, but here we wanted to visualize what is the touch sensation based on this device. And here we created the 2 and 3D plots for you to make you understand what is this touch sensation. So on the 2D plot on the A image, you can see the bigger sphere that we present on the haptic device that we feel on the bigger part of our hand. And then it goes smaller and bigger and smaller. And then we visualize in this way the heartbeat sensation. Here you can see the 3D image that is done within a time domain. So you have like beep, 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 beep shown on your palm. And on the C image, you can see how the haptic pattern sphere changes in terms of the size within a time domain, creating the heartbeat sensation on your hand. We all work in a touchless project, which is the project funded by European Union, and we have the consortium from 6 different institutions. Those are the 3 companies and 3 universities, and we all work on the touchless technologies to create different sensations, to stimulate the user, to put the user into a more immersive world and experience different feelings, mostly those positive ones. And I wanted to make you familiar also with 2 emotional descriptors, which is the violence and arousal. I don't know if you heard about it before, so that's why I wanted to mention that normally we have mostly 8 different emotions. There can be even 20 if we describe them in more details. But here in the project, we've wanted to have the dimensionality reduction, which is pretty common for the engineers currently in the literature. And there are 2 descriptors that combine different emotions. So we have the violence, which describes how pleasant is the feeling, and you can see it on the x-axis. And then we have arousal, which describes how active is the feeling. And it is on the y-axis. So having this knowledge, let's dig into the project. So in this project, we combine different modalities. And I wanted to highlight what is the innovation part here. The first one is that we combine to the visualize, to audio, to speech, also the touch. That has never done, no one has done before. And we created the algorithm that is analyzing the text in terms of sentiment analysis. And the approach is named the hybrid AI, which means that we combine the rule-based algorithm with the traditional machine learning approach to get more detailed information about the emotional context in the speech. Another innovation that we worked very hard on was to create this demo near real time. Since the algorithms for Gen AI requires lots of computational power, and we wanted to have this capability for the users to run it on the normal computer. So we put a lot of effort to combine all of the algorithms, enable the user put the text input to the system, so to create his own story. And then we use the Gen AI algorithms to visualize it in different modalities. Let me show you the example. I will be the speaker over here, how it generally worked during our workday. So this is the haptic device on the left side. We have the cameras that follow our hand movements as well. We have the transducers. This is Kamil from our team checking the quality of the haptic patterns. Those are the examples of the videos that we create. So those are the different stories with the captions as well, to check, to experience what we had in mind while writing those stories. And here we work on the code pretty hard, performing lots of benchmarking tests on the algorithm's quality measurements and also the performance in time. Okay, so when we worked so hard, we had to have the motivation behind, we had to understand why we want to do it, because this is the one of the marker of the success. If we like what we do, if we feel passionate about, then we can say that in the end we got the success. So the first thing that we, when we focused during this all general Gen AI storytelling, was the emotional resonance. As I mentioned, regarding the sentiment analysis of the text, it means that we focus on, beside the context, we also focus on the emotions that are shared within a text sentences. When we contribute to the immersive world, we want to enhance the engagement. We want to raise the memorability because we stimulate the user with more sensation methods. And also we allow the user to put any story as the user wants. So we focus on the personalization as well. If we share the stories between the people, then we can build the empathy. As the engineers, for us, it was pretty important also to work on the technological investments and learn from this project. And I hope you will learn as well after this presentation. And that we all work in competitive edge and work on the new algorithms creations. And this is kind of fun. And then when it came to the implementation, we focus on two major threads. The first one is large language model to create the text narrative. And another one was latent diffusion to create the content of the story. So to create the images, soundscapes in different styles, which is important to mention that we work on the different styles of the presentation to build the best generalized approach for now, but we also allow the user later on to select what style the user might be interested more. And we combine the context, semantics, emotions, and affect. And from innovation point of view, there was the question, how can we generate emotionally concurrent haptics to the stories that we present? And we've done it with a hybrid AI solution, which I'm going to describe you later a little bit, but I will keep you patient a little bit because I wanted to show you how the visualize look like. So let me just mute myself for a kind of 2 minutes to show you one of the stories. It is a positive story, so I hope it will put you in the good mood.
Once upon a time in a quaint little town, there lived a man named Thomas who was deeply in love with a wonderful woman named Sarah. Their love story was a beautiful one, filled with laughter, shared dreams, and endless support for one another. One sunny morning, as they sat together on their porch sipping tea, Sarah shared the joyful news: she was expecting their first child. Their hearts brimmed with happiness, and their home seemed to radiate with newfound warmth and excitement. Thomas, with his heart overflowing, decided to embark on a journey that would forever change their lives. He knew that Sarah had always dreamed of a cozy house nestled among the trees, a place where they could watch their children grow and create countless memories together. So, without a moment's hesitation, he resolved to build her the house of her dreams. He rolled up his sleeves, picked up his tools, and began the labor of love. Friends and neighbors joined in, not only to help with the construction, but also to witness the beautiful testament of Thomas's devotion to Sarah. The house started taking shape, one wall at a time, under the clear blue sky. As the days turned into weeks, and the weeks into months, the house gradually transformed into a charming haven, a true labor of love. With every nail hammered and every paint stroke, Thomas poured his love and dedication into every detail. He added a nursery with pastel-colored walls and a garden filled with Sarah's favorite flowers. When the day finally arrived for them to move into their new home, Sarah was overcome with emotion. She walked through the rooms, tears of happiness in her eyes, knowing that this house was a symbol of their love and the bright future they would share as a family. From that day forward, their lives were filled with laughter and love. They watched their children grow in the very home that Thomas had built with his own 2 hands. The house echoed with the sounds of joy and celebration as they marked each milestone together. Thomas and Sarah lived happily ever after, cherishing not only the dream house, but the enduring love that had inspired it. Their story became a testament to the power of love and the incredible lengths to which one person would go to make their beloved's dreams come true. It was a story of a love so deep and pure that it could move mountains, or in this case, build dream homes, and it was a story that warmed the hearts of all who heard it.
Okay. So it's just general experience. I'm sorry I couldn't share with you the haptic sensation through online because I assume that not all of us have haptic devices at home. And on the right side of the slide, you can see the visualization that was done with our algorithm, that we brainstormed how we could put one slide presentation of how we think the demo should look like. So our dream is to go to Mars. We have the astronaut, right? And the astronaut is kind of trying to touch the waves above the sky. And there is the land behind. This is the moon, right? We go more into the process now. If you have any questions, have you settled to put them in the end of the presentation, or people can ask in the meantime?
People can ask in the meantime. So yeah, if there is a question, because even though I already have a question, but I left them till the end. But if someone also had, please put them in the chat.
Okay, so we have talked about the general goal of this demo and approach. Let me go into a little bit more technical details. So when we were designing the solution, we were inspired by our colleagues' presentation and publication regarding the integrating media haptics into the movie experience, where they stimulate the user with a 1-minute movie together with the media haptics placed here on the sofa. And on the other side, they also had the galvanic skin response sensor, which measures directly the emotional response of the user based on the skin resonance changes. And this presentation and the publication has shown a positive effect of haptic feedback during the first viewing experience combined with the haptic experience, but also a repeated viewing after 2 weeks as well. So it means that they already noticed the emotional correlation when they stimulate the user as well with the haptic device. So having this inspiration from our colleagues, we designed the old solution that combines 3 different threads that works in parallel. Let me first introduce the hybrid AI solution that works on the violence and arousal prediction based on the user text input. And on the other side, we also calculate for each word the importance in the emotional context. Then we combine the results with previously gathered the haptic patterns database, which we gathered by the case study, where we asked the people how they generally would describe in emotional sense of violence and arousal different haptic patterns. Predefined haptic patterns were evaluated by the group of the people, assigning the different values of violence and arousal to each haptic pattern. And together with another thread, where we use the text-to-speech algorithm from Azure, we created the speech content. Then we created the timestamps based on the whisper algorithm for each word. So then we could combine the selection of the word importance together with the proper haptic pattern selected that is suitable for the selected emotion. And then we could create the haptic sensation in the end. The difficulty here was also not only the word selection, it was also the length of the sensation to make it strong enough and long enough to create and enhance the emotions. And the last thread was the image and audio generation. So we used the Mistral algorithm to create the text prompts, which then were fed to audio LDM second algorithm to create the background sound, which you could already hear, I hope, in the demo. And on the other side, we also used the same prompts to the Dream Shaper 7 algorithm to create the image content. Then we combined the speech, the audio sound, and the images together with the video. And in the last step, we combined everything together. So there was the major question to our system, when to add the haptic stimuli, how to do it, honestly, and which haptic pattern to apply to create a multisensory storytelling experience. So when creating the system, we divided the haptic part with outside of the audiovisual part of the solution. So regarding the touch creation during the storytelling, we worked on the hybrid AI solution. We designed that. So we have the input sentence, which then is fed into 3 different approaches. The first one is the BERT algorithm, which calculates the violence and arousal values based on the whole sentence. Then we have the Vader algorithm, which calculates similarly, but based on the knowledge-based violence prediction approach. And then we also have the NRC lexicon, which provides us the arousal level. Then we combine all of the results together to get the final hybrid AI violence and arousal prediction. Sounds easy, but it was not that easy to perform. So let me show you how we dig into the results. So here you can see the graph from our case study, where we presented 14, I have to check, different haptic patterns to the users. And then we ask each user for the violence and arousal description. And we ask 21 people and then calculate the average violence and arousal values for each haptic pattern. And then when we presented it on the 2D shape, we realized that the patterns are clearly separated, and we could then perform with the further algorithm development. When we were designing, we have to also perform the test part, and the whole team, together with the Ultraleap team, met in one place. Then we were brainstorming what kind of the stories we could visualize and experience. And we did a huge brainstorming regarding the topics that we would like to fill and would be interesting in further development. And we selected 3 different areas here. The first one was the positive video, the another one was the negative video, and the third one was the variational video. So you can see here the images that we created based on the initial story here created as the example. So when we designed the story, the text for the story, the next step was to talk and somehow design when the stimuli should appear, the haptic stimuli, when should it happen. And then we plotted for each sentence of the story the violence and arousal values and selected the highest peaks that could be then combined with the haptic stimuli. And when we talked about which haptic patterns, then with the distance algorithm, then we could select the haptic pattern that was the closest in the sentiment values to the ones that were presented in each sentence of the story. Yeah, I think I can ask Kamil to jump in here to talk about the image generation.
Thank you, Daria. So I'll try to now go briefly through some generative AI components of our whole pipeline, and I will start with the large language model we use. So in general, in our pipeline, we use LLMs to generate the prompts. And before I jump into the concept of prompt generation, let me try to discuss some technical details about the model that we use. So we use the Mistral 7B model, and to be more precise, we use the Mistral 7B instruct version. This means that the model is followed by some instructions that are being input by the user to create the desired output in like a sort of conversational concept. So in terms of architectural innovations that are implemented in the Mistral 7B, we can mention 4 main contributions. So first of all, Mistral 7B uses sliding window attention, and this handles long sequences more effectively at also a reduced computational cost. So in sliding window attention, the attention mechanism moves over the sequence in a sliding window manner, and this enables us to obtain results in a very short time, and also without losing any sort of information. Secondly, also grouped attention is applied, and in grouped attention, this is also an attention-based mechanism where the queries are grouped together before computing the attention weight. So also using grouped query attention accelerates the whole inference process and speeds up like the generative process itself with reducing the memory requirements during the decoding phase. Third part is the rolling buffer cache, which is also very important because, as we know, we have a limited cache size. And in terms of LLMs, this limited cache size corresponds to a limited number of tokens that we can fit into the cache. And rolling buffer cache solves this part by removing the tokens that have been inputted in like first steps, such that when there are another tokens that have to also be filled to the cache, but there is no space in cache, we can remove the first tokens. And because of using sliding window attention and grouped query attention, we can still obtain the attention weights on this point. Finally, there is also a prefill and chunking part. So in generative process of the language models, when the sequence is generated, this is most commonly done in a one-by-one procedure. So we generate one token, then another. But what we can do before is that we have the prompt known in advance. So this is done by filling the cache with the prompt. and then working on the field catch with this prompt. And also, when the prompt is too huge, too large, we can try to split it into smaller parts. And so we can chunk that prompt and fill the catch with only chunks of the prompt. And because of using the previously mentioned sliding window attention and grouped query attention, we can still obtain a very satisfying results on this point. And so as you can see on this table on the right, Mistral 7B instructs outperforms most of the 7 billion parameter models, but also outperforms some 13 billion parameter models. So we decided to go with Mistral 7B instruct for the next steps, which is the prompt generation. So prompt generation is very crucial for any sort of text to some modality pipelines, especially text to image and text to audio. And so how we can do it? First of all, we obtain some user input, and then we try to generate the prompts. So as Mistral 7B can be used during the inference as an instruction model, we input to the Mistral exemplary sentence and the corresponding prompts to this sentence. And then we ask Mistral 7B to generate prompts for another sentence. So here's the example. We input to the Mistral 7B instruct following sentence. Under the midnight sky full of twinkling stars, the UFO ship emerged on the horizon. And so we also provide it with the other exemplary sentence and exemplary prompt, and we obtain the following prompts. Midnight sky, star-studded, UFO appearance, horizon, nighttime, alien spaceship, twinkling lights. And then we can use these prompts to the image generation pipeline. So in terms of image generation from text, most commonly used methodology nowadays are the latent diffusion models, especially the stable diffusion, open source one, which has a lot of different checkpointing approaches and also a lot of different styling we can apply. So one of our goals was to experiment with very different checkpoints, very different styling and other models that can be applied to stable diffusion. So here's the example of a prompt, 3 red sport cars racing towards sunset, Miami Beach, backdrop with purple-yellow sky. So also you can see some images generated by the following algorithms. We have Stable Diffusion 1.5, also with Disney styling, we have Dream Shaper 7 and latent consistency. So you can see that each of these images provides us with some satisfying output. But the question we had was which of them are visually the best. So we ran a sort of a case study where we tried to benchmark some most commonly used models. And we evaluated the obtained images in terms of 2 metrics. So first one was the image quality preference, which means that the user was asked to select the picture that is just visually the nicest. And the second metric was a prompt alignment preference, which means that for the given prompt, which of the images is mostly fitted, which of them is like mostly closest to the input prompt. And as you can see on this bar plots on the right, Stable Diffusion XL is really like the main competitor in that direction, and also Stable Diffusion XL Turbo with some Disney styling. But additionally, you can also see that the Dream Shaper models also perform pretty nice in terms of both image quality preference and also prompt alignment. So we had to go to find a trade-off between the generation time, such that the model generates the satisfying image in as quickly as possible manner, because we wanted to interact to this new real-time regime, and also the model that will provide us with the total preference score as high as possible. So it turns out that Stable Diffusion XL Turbo with Disney styling, Dream Shaper 7 and Dream Shaper 7 with Disney styling provides us with the best results. And what was also important for us in terms of the memory consumption, we in final selected the Dream Shaper because this is built on top of Stable Diffusion 1.5, which is definitely more light model than Stable Diffusion XL. So with that, we move to the final part of image generation. So the whole pipeline. First of all, we have the prompts, which we obtained from the Mistral 7B instruct model, and then we input them to the Dream Shaper to generate the image. We can optionally also use some additional styling, like this Disney style. If you want to have the whole story in, for example, like the Disney style, and also latent consistency model, which also speeds up the generation process to obtain the image. So here's the example. We have the prompts which were previously generated: midnight sky, star-studded, UFO appearance, horizon, nighttime, alien spaceship, twinkling lights. We feed them to Dreamshaper and obtain the image of the UFO somewhere in the sky with the midnight and the stars. And that's all regarding the image generation.
Mm-hmm. And another thread was to create the audio background experience. And we applied, based on the prompts from the Mistral, we applied the audio LDM algorithm, which uses the self-supervised pre-trained audio mask autoencoders and latent diffusion models to create the background audio. So as Kamil mentioned, we had the same text prompt here, and let's check the audio now. And for each sentence, we created the different image and the audio. Okay. Another track was to create the speech, the narrative of the storytelling. So the major thing was also the computational time. So we used the Azure text-to-speech algorithm to create the speech content, and then we needed to have the timestamps. And we use the Whisper algorithm to perform the automatic speech recognition and perform the time stamps when which word in the sentence started and ended. So we have the same text prompts as the example that we fed it into the Azure text-to-speech. So let me just give you a quick example.
Under the midnight sky full of twinkling stars, the UFO ship emerged on the horizon.
And then we had the start and the end of different words spoken in the story. When we focused on different sentences, then we had to combine them to make the smooth experience. So for the image, we used the interpolation method, and for the audio, we used the adaptive music algorithm to make smooth changes between different audio files or the images. And here is the pipeline for the time calculation based on the initial text input from the user. So here we just limited the length of the sentence from the user into the number of 3. And then we allowed the algorithm to run everything in parallel to get the best benchmark as possible. So here you can see that the 3 sentences, I would say mid-length or even quite long, took a little bit more than 45 seconds to compute and present it to the user afterwards for all of the modalities provided here. So that's why we call it near real time. So as I mentioned, we created initially 3 stories for the testing phase, the positive, negative, and with the changes in motion to see if the haptic with the multimodality approach could enhance and gain our goals. So we have performed the user case studies of 12 participants with those 3 stories and 2 conditions. One was synchronized with the haptics, and another one scenario was that we presented the haptics randomly with different haptic patterns in different time zones. And then we performed different questionnaires to get the subjective assessment from the users if they felt more engaged or if they felt more immersion. And what happened was that we influenced actually the emotions of the users in the end in the synchronized approach of the algorithm. The people felt more immersive, they felt more affect of the presented context of the story, and that was the goal actually that we were looking for, and we were very happy to see the results that when we synchronized the haptics, it had the positive effect of the on the user. And when we were designing the haptic patterns, this is the last thing that I wanted to mention during this presentation. We were thinking about the innovative solutions, how we could select different haptic patterns in terms of the emotions. And we have developed the algorithm that is based on the embedding space of different haptic patterns. And we performed different algorithms for the embeddings, and then realized that when we put all of the haptic patterns that we created into the 2D shape, then we see that some of the haptic patterns, you see they cluster in the space, which means that if we want to jump from one emotion to another one, that we can change the cluster probably. But this is something that we are currently submitting to one of the conferences papers, and let's see, fingers crossed, that we will be accepted. So here you can see the example when we have the sensation presented over here from this cluster. If we want to change it, then we can jump to another cluster. Of course, we define the distance from one cluster to another, which we work currently on. And we're coming to the end of the presentation that I wanted just to summarize that we created the Gen AI algorithm for the storytelling that combine all of the modalities that are capable to run even online if we have the haptic device. So we stimulate the user with the images, with audio, with the speech, with the touch as well, to create fully immersive story in digital world. And now we can dig into the question part.
Yeah, thank you, Daria, for the presentation. I believe the overall work is done with your team in terms of building this custom pipeline is amazing, especially running it in near real-time conditions. As Vadim Miknevich mentioned on the workplace, it's really easy to imagine how this technology can be used in movie theaters, where haptic devices are kind of in the chairs, and but then it's probably will be more expensive as any kind of more immersive experience that are already on the market. And in this regards, I have a question to ask. Maybe from some perspective, provocative, right? Because it's interesting to challenge the outcomes, because everything cannot be so amazing. But so let me ask the first one: can this custom pipeline in its adoption be reused for another haptic device, for example? If we want to increase the adoption, for example, use on the mobile phone, where is the haptic usually is a part of the phone, or I don't know, any other kind of device like game controller or something like that.
The only thing that we could adapt here is the creation of the haptic pattern pool that then we combine to the sentiment analysis of the text. But yes, yeah, when we were creating this approach, we thought about different scenarios as well.
Really cool.
That's a good question. Thank you.
One more interesting question. Let's imagine, for example, there is the customer or the person who want to implement this end-to-end custom pipeline for their purpose. Can it be fine-tuned on specific, I don't know, brand data or any other kind of data for each of the model used here? So then it will, I don't know, show the immersive stories that showcase specific company or the specific narration, like, I don't know, Disney narration in the way that's needed in terms of image generation, audio, and also haptic devices. So is it the way this model can be fine-tuned, or it should be just retrained or from scratch, or yeah?
Yeah, that's a great question that made me think how to make it. If I understand, for example, there would be the company that is interested in the drinks, let's say. So we would like to show the content that is close to the drinks, right? Yeah, I think we could work around fine-tuning initially to check the quality in the end. Yeah.
Okay, and And the last question you already answered was around real time, and it's really amazing that all the models are so optimized that can be run in those kind of near real time conditions. And I suppose just if to take more complex models, it'll just take more time for this initial computation, right? But is it the chance to prolong the story? Kind of, yeah, let's go ahead, generate some more, or like let's have a second chapter, I don't know.
Exactly. Yeah, so we run it on the simple laptop computer in terms of the time benchmarking. But if we had the stronger computer, it would be probably much faster. So we wanted just to have this tool capable to run on normal equipment. So that
And
was
what
the
was the
goal.
equipment, if it's not a secret?
We had one GPU 270. Kamil, was it right? Do I remember correctly?
Oh, yes, I do think so.
So yeah, cool. Quite effective. Quite effective. Okay, so for now I see no additional question on the workplace and here in Zoom, and it means that the story was really comprehensive and end to end. And thank for you presenting it. I believe if someone has question for both like more related to the use case itself or technical one, you can reach out to Daria and team to ask them in person. And that's it. Thank you, Daria, for presenting.
Yeah, thank you. If you're around the Krakow, we can show you that, or in Wrocław.
Oh, really good action item. So everyone who watched today's session, and if you live in Krakow or around, you can also reach out to Daria and try this storytelling itself. Thank you so
Thank
much
you so much
for joining.
for your time.